All right, hey geometry class, Mr. Ludd here. This is Unit 4, Lesson 1, CP1, Lesson 1. We're going to define and draw a diagonal, recognize the difference between equilateral, equiangular, and regular polygons, as well as classify polygons, up to 12 sides. Okay, so the following items on the left side are polygons, because they are enclosed. As you'll notice, there is no open space. If you trapped a fly inside of these objects, they wouldn't be able to get out. No way out. The other items over here to the right side are not polygons because they are either one, not connected by segments, like this one, this oval, needs to be connected by flat segment sides, as well as needs to be enclosed. So these two right here are not fully enclosed. Of course, there's the definition of a polygon: a closed figure in a plane formed by two connecting line segments to each other. Okay, classifications of polygons. You may or may not remember these, but the list right here is all-inclusive. And as you go down, tri means 3, quad means 4, penta means 5, hex 6, etc., all the way down. We use n-gon for anything above 12 sides. So a 96-sided figure would be a 96-gon. Do you know, there's a joke out there. Well, it's not going to be that funny, so I won't tell it right now. Okay, polygons, like we talked about on the earlier slide, are enclosed by line segments. Some polygons are convex and others are concave. I'm going to highlight the concave ones here in purple. And I want you to pause the video and tell me, oh, that looks like red, but it's supposed to be purple. And I want you to pause the video and tell me why you think those are concave and not convex. Okay, so we're back. These are concave because, and it's as easy as this, but there's a caved in portion, right? If I draw a segment from one vertex to another and it's outside the shape, then it's concave or pushed in. These items right here are convex because any diagonal that I would draw would be inside the shape. Right? I could draw a diagonal in these other ones and they wouldn't be inside the shape. So concave is pushed in, convex you could think of as not pushed in or not concave. Here's the difference, you guys, between equilateral and equiangular. Lateral means side. Side, I'm going to try to spell things. That's a D. Side. Equiangular means equal angles. So clearly in these shapes over here to the right, I have polygons. They are convex polygons and they're equiangular. How do I know that these 6 angles are the same? Well, because they're marked that way. Otherwise, I might not know that, right? Those are all equal because they're marked that way. Over here on the left side, I don't know about the angles, but I do know about the sides. I know that these are all the same, and so are these in this concave polygon. So these are called equilateral on the left side and equiangular on the right. What if the shape is both of those? Well, if it's both equiangular and equilateral, it's called regular. Well, a regular 4-sided shape, what do we call that? That's called square. Okay, same thing in a pentagon. That doesn't have a special name. It's just called a regular pentagon. I'm going to shorten that up. And then over here I'd have a regular, see if you remember, pause the video if you don't, 6-sided shape. This would be a regular hexagon. Spelling, not so good, but you get the picture. Okay, so that is a regular shape, which is both equilateral and equiangular. Now, how can we name polygons? When naming a polygon, you use the vertices. So I would name this pentagon, and then I'd give letters to it. Now, the only designation that's necessary here is that all 5 of the letters are used, and they go in order around the shape. So I could call it A, B, C, D, E. I could call it E, A, B, C, D. Okay, I could call it A, E, D, C, B. But I cannot skip around to non-consecutive vertices. Okay. Of course, I'd use the word pentagon before that. When naming a triangle, we don't have to write out triangle, we just write out the symbol for a triangle. I could call this triangle TSU. I could call this triangle STU. I could call this triangle UST. You really can't screw up a triangle because all vertices are connected to all other vertices. So make sure and use the triangle symbol so you don't confuse your teacher. Thank you. Okay, a diagonal, you guys. A diagonal is a segment from one vertex to another non-consecutive vertex. So there's 3 vertices, there's 3 diagonals coming out of there. I could name those diagonals TM and MH and MS. Okay, there are a few more diagonals involved. I've got AH, AS, and AE. All of these can be written in the opposite order. I've got TH and TE. Look at this, it keeps reducing by 1. That's so weird. And then I've got HE. So those are all the diagonals of the following hexagon. There you go. I don't think I missed one, did I? No, I think I'm connected to all other points. Cool. All right, what does it mean for 2 triangles to be congruent? Well, it just means that their corresponding sides are congruent, and their angles that correspond are congruent. So look at this. AB is congruent to XY. Now, it's important, though, that AB is congruent to XY. AB is not congruent to YX. AB is not congruent to YX. Now, let's look at Y. Notice that A is up here, and Y is down here. Okay? A and Y don't correspond. A and X correspond. B and Y correspond, right? These 2 correspond right here. Therefore, AB is congruent to XY. If you want to, you can pause the video and determine, what you think your answers should be for AC and BC, and then come right back. So triangle ABC is congruent to triangle XYZ, and that is because A corresponds to X, and B corresponds to Y, and C corresponds to Z. That's why I have this very specific order here. Okay, so then that just follows the rest of the way. Well, I know A corresponds to X, and C corresponds to Z. Okay, same thing for BC. I know that B corresponds, I've already labeled it as corresponding to Y, and C corresponds to Z. So I know that segment BC corresponds to segment YZ. Notice order matters. I don't want purple-green if I'm starting here with green-purple. Okay, use highlighters. It's helpful. We're not going to do pair deck, not on this video. And I think that's it. Okay, so corresponding parts of congruent triangles are then congruent. A corresponds to X, therefore B and Y, and C and Z. That's why the order will matter. All right, guys, that's all I got. Hopefully this goes well. We can ask some questions in